Well, hello there, good people of the internet, and welcome back to another episode of Quantitative Bytes. I hope you're all doing well. So I wanted to kick off something that might grow into being a new series. And one of the things that frustrated me a little bit with the work that we did previously on the ray tracer was that it wasn't possible to create any kind of display directly. So if you remember back from the ray tracing tutorial, if you haven't seen it, I'll put a link up in the top of the screen. It'll be about here and or this side, wherever they come. It's confusing anyway. And so what we did, we wrote a fully functional but simple basic ray tracer using nothing but the standard libraries in C++. And that's kind of cool. I really like just doing things like that from first principles, using only the standard libraries. And at the time I made the argument that this was good because it meant that we're creating something that was inherently completely cross-platform. So that code for the ray tracer could be compiled on any system for which you have any reasonably modern C++ compiler. And that's possible because it only uses the standard library, so the standard things that C++ comes with. But of course, once you start doing that, you inherently bring in a certain number of limitations to what you do. So one of the things that we just couldn't do was create any kind of graphical output to the display, to the screen, because the standard libraries for C++ don't contain any of the functionality required to do that. So what we did instead was we created a class that at the time was called QBImage, and this allowed us to set pixels on the screen, in an image, not on the screen of course. This allowed us to set pixels in the image to whatever color we chose, and then it allowed us to save that image out as a device-independent bitmap file. And then we could view the output. We could view that file using any standard image viewer app. So in that way, it was possible to see the output of our code. So we would run the code, it would do its ray tracing, and it would create a file on the disk with the output, and then we would have to use a third-party image viewing program to display that image to see what the output of our code was. And that's absolutely fine, really. I mean, it's simple, it's basic, but it really does work. But it's a little bit frustrating sometimes, and it's quite in contrast to the work I've done recently on this channel using Python, where we use Python and Pygame. Again, I'll put a link up here to those videos if you want to go and have a look at those. So we use Python and Pygame to look at exploring the Lorenz attractor and also implementing random walks to make a model of diffusion limited aggregation that we then use to simulate the process by which frost is formed. And that was all kind of exciting, but what made those programs in a way more interesting was that they produced their display directly on the screen, so you could see what was actually happening as it was happening. And I've been kind of thinking that actually that would be kind of good to be able to do the C++ stuff and have something similar, so we can actually write code, and then when we run it we can actually really see what's going on in real time as it's happening, in the same way that we've done with the Python code. Now, this means, of course, introducing another library, so this is sort of breaking with my previous philosophy of developing using nothing but the standard libraries, but I think it's acceptable. I want to try and keep the number of libraries I introduce into my C++ code, especially for this channel, to a minimum, so as to maximize, cross-platform compatibility, because I run Linux, but I'm conscious that, many of you don't. Most of you statistically probably use Windows, and then Mac, and probably Linux is somewhere down at the bottom. But I want to write code that anyone can use, right? So that it doesn't matter. So you can follow along with my tutorials using whatever platform you happen to have. That's really my goal. I want the maximum number of people to be able to get something out of these videos. If I just did stuff just for Linux, I think that would be really a relatively limited interest. So that's kind of my philosophy. Now, there are a couple of libraries for C++ that we can use to achieve this, and there are two that immediately spring to my mind, and these are SFML and SDL. Now, out of those two, I've plumped to use SDL, which stands for Simple Direct Media Layer library, and there's no obvious reason really why I went with SDL over SFML. It's simply really just personal preference. I mean, I'm not I will put this out there, right at the beginning. I'm not particularly familiar with either, and we're really going to be kind of learning how to use these libraries together as we go, because I haven't really worked with them very much in the past. But in any case, I've plumped to go with the SDL library, and that is extremely cross-platform. This is one of the reasons I picked it. I mean, SFML is very cross-platform too, but I think SDL, as far as I can tell, and apologies to anyone if I'm wrong, but I think SDL is very slightly more cross-platform than SFML. So even though I'm now using an extra library, anyone wishing to follow along with these tutorials, you only have to install the library yourself, and it doesn't matter whether you're using Windows or Linux or Mac, you should be able to follow along, and the code should work for you, exactly the same code. So that's the point. It's a cross-platform library, so the code that we write in the tutorials won't change depending on what platform that you're running. I think it's important to say a little bit about what SDL is and what it isn't. So SDL is really a very simple low-level library that basically allows you to create a window on the screen and draw stuff into that window. It also has tools to handle user interaction through like the keyboard, mouse, joystick, or game controllers, that kind of thing. It's got simple interface to audio, the audio subsystem of whatever operating system you're using, and a few other things as well that we don't need to talk about. But of course, what's of real interest to us is the access to the screen. So it gives us the tools that we need to be able to create a window on the screen and then draw things into that window. Now, what it isn't is a GUI library. It is not a library that is designed to give you all of the elements and things that would go into a graphical user interface. So by that, I mean things like buttons, text boxes, list boxes, all of that kind of thing. SDL doesn't provide any of that. As it is out of the box, if you wanted to implement sort of buttons that the user can click on, you could do that, but you've got to write that code yourself, right? So you would have to write your own code to render the buttons and to handle the user interaction and things. And this is something I'm learning about now. And like I say, I haven't really used the SDL library before coming to use it now for these tutorials. So I'm not by any means claiming that I'm an expert with it. But it seems like it pretty much does everything we want, really. So what we want is a system for C++ that allows us to replicate essentially the code that we've used in the Python tutorials that I've done recently, and SDL really ticks that box. So SDL is pretty easy to install on Linux. It's available, I run Ubuntu Linux, it's available in the Ubuntu repositories, so it was just a matter doing sudo apt-get install SDL, I think 2.0, that's the newest version. But in any case, if you just go to the SDL website, which is at www.libsdl.org, and you can just follow the instructions on how to install it for whatever platform you're using. Like I say, for Linux it was incredibly simple. For Windows, I think it's quite basic. It comes with a CMake package, and you can then use CMake to generate project files for Visual Studio. So if you're using Visual Studio as your IDE, you should be able to get up and running pretty quickly. I don't have access to a Windows machine, so I haven't been able to test any of that, but I assume it's pretty straightforward. So if you want to follow along with this tutorial and the other ones coming up in this series, that is the first thing that you need to do, is go to the SDL website, follow the instructions on how to download if necessary, and then how to install the SDL libraries, and then you really should be able to follow along. So what I really want to do today is just show how to very basically use SDL in some code. We're just going to create a window and draw a red rectangle into it. Really nothing terribly exciting, but it will just provide a platform that you can test. You can use this code to test that your installation of SDL and everything works. Like I say, I was able to install SDL on my Linux system without any problems. That was very straightforward. I have no idea about installing it on any other platform, so apologies if you have problems with it. I'm really not the person to ask, okay? But I mean, let me know if you have issues, and maybe we can explore that together. But I don't really know, and like I say, I'm not pretending to be an expert with SDL, so we're kind of going to explore this together, I think, as we move forward. Anyway, that's enough talk. Let's jump in and have a look at some code. And we're going to look at how we would flesh out a very basic framework that we could use then to create games or animations or whatever in C++ using SDL. Okay, let's go. So I'm here at my text editor. You can, of course, use any text editor that you want, or integrated development environment, or whatever it is you prefer. So we're going to create, first of all, our header file. So we're going to create C++ code that we're going to call capp. So we need to create capp.h and capp.cpp. So this is going to be capp.h, the header file. So of course, as with all the code we've done before for the ray tracer, we start with the include guards, just as before. End if, right, and now we've got that, we can go ahead and save that. Okay, and we go ahead and we save that as capp.h. And the first thing that we need to do is to actually include the SDL library. So we just do hash include, and then it's sdl2/sdl.h. At least that's how it works in Linux. I think this code would be exactly the same if you were running on any other system. If you look on the SDL website, as I've mentioned, in fact, I'm just going to put that in the comments here, just so you can see SDL website. It's not a comment in C++, apologies. Is there. So libsdl.org if you want to go to that. Anyway, so we're going to create a class called capp, just like follows, just like that, pretty basic stuff. And we're going to declare a bunch of public functions. So we have, first of all, the constructor, the default constructor capp. And we're then going to have int on, I prefer to use that one, on execute, like so, bool on init. Now, anyone that's been following along with my Python tutorials, you will notice that this is a very similar layout. So very much as we did with the tutorials I did for Pygame, we have exactly the same structure. We have on execute, on init for initialization, on event for handling events. Notice that we use the SDL event type, and we create a pointer to that. And then we have void on loop, void on render, like so, and finally void on exit, like that. Now, like I say, it's very similar to the structure, if not really identical to the structure that we've used for the Pygame tutorials that we've been doing, which I think is quite nice. So bool is running as a flag to tell us whether our code is running or not. And now one thing that is different is we need to create a pointer, star p window, like so, and a render. So we create a pointer to our window, and we create a renderer, which is the object that actually handles the rendering of our display. And that is everything that we need for capp.h. Okay, so really very, very simple. What we're going to do is we're going to create a new file now, and we're going to do, this is going to be capp.cpp. So our first line, hash include, obviously capp.h, bring in our header file, and we go ahead and save that as capp.cpp. All right, so we start with the constructor, obviously the default constructor to begin with capp : capp, like so. And we need to configure a few things here. We set is running to true by default. We set p window to null and p renderer to null. We'll just get those as null pointers. Okay. Now we're just going to work through each of the methods from our header file. Bool capp : on init. So this is our code that handles the initialization. So the first thing we need to do is tell SDL to initialize anything, and we do that with the SDL _ init command, and we tell it to SDL init everything. That I presume tells SDL to initialize everything that we need. If that is less than, returns a value less than 0, then we know we've had an error condition and we simply return false. Okay. If that was successful, now we can create our window, which we want to store a pointer to our window in our p window member variable. So we do SDL create window. We're going to give it the title test window, which I think makes sense. And we do SDL window pause centered, and SDL window position centered like that, that will make the window in the center of the screen. We make it 640 by 480 pixels in size, an SDL window shown. Okay, I'm not an expert in SDL. I don't absolutely know what all of those means. Now, assuming that was successful, we then want to go on to create our renderer. So if we do if p-window is not equal to null, now we can, so that means the window was created successfully. So now we can go on and we can create our renderer, create renderer, like so, to p-window -1 and 0. That will create our renderer instance. If, on the other hand, p-window was still null, then we know that something has gone wrong and we just return false, like so. And if we make it all the way through there, then everything was successful and we can simply return true. So that is everything we need to initialize our system. Now, the next, if we go back to capp.h, the next one that I want to do, that was on init. So we're going to do on execute next, okay? So this returns an int, capp : on execute, accepts no input variables, and there it is. So first of all, we need to create an event object, object of type SDL event, and then we call on init. If on init returns false, then we're going to return -1, which will indicate an error condition. If, on the other hand, we make it through that, we begin our while loop and do while is running. So is running is this flag that we set initially here in the constructor to true. So while is running is true, we're going to look through all of our events. And we do while SDL poll event reference to our event object is not equal to 0. So while there are still events in the list, we call the onEvent method that we haven't written yet, and we pass to it the reference to our event object. Okay. And then, exactly the same as we did with the Pygame tutorials, we then call onLoop and onRender. Okay, and that is actually more or less everything that we need on execute. So while is running is true, this loop will just run forever, and it will just call, it will poll, every time it comes through, it will poll through all of the events in the queue, call the onEvent method with each event in turn, and then once it's finished that, it will then call onLoop and then onRender, and like I say, it will keep going until is running is false. And when that happens, we then want to call onExit and return 0. And that is everything that our code is going to do. I just want to just space that out a little bit. Okay. So we call the onEvent method there, so it would make sense just to have a look at that next, I think. So let's have a look. We do void. It doesn't return anything. Capp : onEvent. This is SDL event. We get a pointer to an event object, so we do it like that. Just bring that up like so. Okay, and all we have to do is query the event type. So if event type is equal to SDL quit, right now that's the only event that we're concerned about, then we set is running to false. And that is everything we need to do. That is all of the events that we need to handle in this instance. What else have we got? If we look back to capp.h, we have onLoop and we have onRender. So let's have a look at those. So onLoop in this example, we don't need to do anything. So we just onLoop, sorry. So we just define onLoop, but we leave it blank. And we are going to do everything to make our example in onRender. Okay, so the first thing we're going to do here is we're going to set the background color to white, and we do that with SDL set render draw color and pass the reference to our renderer, p-renderer, and then we just set this to 255 for red, 255 for green, 255 for blue, and 255 for alpha, and then we just do call SDL render clear and pass to it a pointer to our renderer. Okay, and then we are going to draw a red rectangle. That is as much as we're going to do for today. It's not tremendously exciting, but it will be enough to demonstrate that our code is working as it should. So to draw a red rectangle, simply do SDL rect fill rect is equal to, and I'm going to specify this as being at 150, 120, and then these are width and height. Okay, and we need to set render draw color. Again, with a reference to our pointer to the P renderer. I'm going to set this to red, so that's 25500 and an alpha of 255. And then we'd simply call SDL render fill rect, like so. Pass to it the pointer to the renderer and the reference to the fill rect that we've just created. And finally, we need to show the window, show the result. If we just leave that, then nothing will happen. And then we simply call SDL render present and a reference to our renderer. So that will cause the renderer to actually do what it's supposed to do. And that is everything we need for the onRender method. So we're nearly there. Lastly, I think we've done everything now. We've done onExecute, onInit, onEvent, onLoop, onRender. So lastly, we just need onExit. So this is the method that will just handle cleaning up everything. So capp onExit, and we're simply going to call SDL destroy window p window, like so. P window equals null, and SDL quit. Just that. Okay. Now, if we were to compile that code now, it will produce an error because what we haven't done is declared any kind of main function. So we need one more new file, which is going to contain our main code. So this is going to be hash. Let's hash include capp.h to bring that in. So I've saved that now as main.cpp, and then we simply declare int main, int argc, this is standard stuff, char star arg v square brackets. Okay, so this is going to be the main entry point for our code. We create an instance of capp, which we're just going to call the app, and then we simply return the app.onExecute. Okay, so we create an instance of our app by an instance of the capp class that we've just created, and then we simply call the onExecute method, and that should make our code run. Now, what we need to do is now to compile that. Okay, so that's quite easy to do. So in order to compile that, it's pretty straightforward and not too different to what we did with the ray tracing tutorial before, but there is one slight difference. Now, I'm doing this from the command line in Linux using G++. If you're following along using an IDE such as Visual Studio or something like that, then I would encourage you to look at the instructions on how all this works in the SDL website. I think they're quite clear. So anyway, if you're doing this from the command line in Windows using MinGW64 or MinGW64, I'm never sure exactly what it is, then yeah, again, instructions there on the SDL website. But in that case, then I guess the way you would do it would be much more similar. So we should have in our folder now, we have the three files that we've created: capp.cpp, capp.h, and main.cpp. Now main, this is our main, main.cpp contains our main entry point, and capp is our class that contains the code really for our application that we've written. So to compile this, we just do G++, and we're going to specify -o main, because that's what we're going to call the final executable, and we are going to compile main.cpp and capp.cpp. Now if I just run that now, it isn't actually going to work. And then we need to tell the linker that it needs to reference the SDL libraries, and we do that with an additional switch, which is -l SDL2, just like that. So what that will do, so the compiler will compile our two CPP files, and then this tells it that it has to go and find the SDL libraries in order to link against those to actually run to generate the final executable. So if we press enter to run our compiler, oh, okay, yes, apologies, I have made a simple error there. Yeah, so line 76 in capp.cpp, yeah, I understand, that's where we initialize the rectangle. Of course, yes, here we go. Here we are, line 76. those are curly braces. That's really important. So that brace there and that brace there, those are curly braces around the parameters of the rectangle. So save that again, bring back the terminal window, let's just clear it. Now let's run our compiler again. Okay, and that compiles without issue. Okay, and then to run it, if I just do /main, we should run our code, and there we are. Okay, so that is the result we get. We have created a window, we've colored it white, and we have drawn a red rectangle into it. Now, that isn't tremendously exciting, but it is enough to demonstrate that we have correctly installed the SDL libraries and that everything, at least in terms of the functions that we've used here, is working exactly as it should. It's worth noting that this hooves up quite a lot of CPU power because it's looping as rapidly as it can and it's constantly refreshing, which is perhaps not what we want for everything, but that's something we'll look at when we come to it another time. Okay, so that's actually everything I wanted to talk about today. We've talked about the SDL library and we've talked about why we're using it and how it allows us to create visual displays from our C++ code, which I think makes things quite a bit more interesting than the way we were doing it before, where we simply had to create a file on the disk and then view the output using an external image viewing app. So what we can do now is we can create a window and we can draw stuff into that window and we can see the results of our code immediately. This is also structured in a very, very similar way. The way we've set this up with our app class, it's very similar structure to the layout we use with Pygame and the two tutorials I've done using Python and Pygame. And that, I think, is quite a good way of working. It's not really the only way of setting these things out, but I think it's quite a nice way of doing it. I quite like having the onLoop method separate to the onRender method. So the idea is, of course, you put any calculations and things you need to do in onLoop, and then onRender is just responsible for actually producing the display. But if you followed that along, you should now have this working. So we now have the SDL library installed. We're able to create a basic window and render something into that. And that is a really good starting point, I think, for what's going to come next. And I think a really good point to finish for today. So listen, I hope you found it useful. Please let me know in the comments below what you think, if you have any ideas of other things you'd want to know. And like I say, I'm not trying to claim I'm an expert with using SDL. I'm really not. This is something we're going to explore and learn about together, I think, as we move forward, which I think is quite exciting. But what I want to move on to next is implementing turtle graphics in C++, and that was actually kind of the inspiration of why I wanted to use a library like this, so that we can visually see what's going on, but that will be for the next episode. Anyway, listen, if you've liked this video, please do hit that like button, and please remember to subscribe to my channel so you don't have to miss any future videos. Listen, it's really been a pleasure. I hope you found it useful, and I really look forward to seeing you in the next video. Bye!